Question 6. Now, looking at the diagram here, I think we're going to be dealing with circle theorems. Okay, we're told that A, B, C, and D are points on this circle. That's how it's drawn. We've got a tangent to the circle, and look at that. We've got AB equaling CB. So we've got the makings of an isosceles triangle there, haven't we? Okay, let's draw this point here. Okay, now I've drawn that, I can see we might be dealing with alternate segment theorem as well. Right, angle BCQ is x, that's labelled already. Prove that angle CDA, that's this angle here, so that is our target. And we have to prove that that equals 2x. Let's have a look. Well, the first thing I reckon is that I can find this angle here, angle CAB. Well, that's x because of the alternate segment theorem. Okay, and now, therefore, this angle here is also going to be x, right? Because that's an isosceles triangle. So ACB equals x because ABC is isos. So that means that this angle here, ABC, is going to be 180 minus 2x, isn't it? Okay. Oh, now just a minute. You know how opposite angles in a cyclic quadrilateral have to add to 180? That means that this angle and this angle must add to 180. So ABC plus CDA have to equal 180. Opposite angles in a cyclic quadrilateral. I'll leave you to write that out in full hand. So ABC is 180 minus 2x plus CDA has to equal 180. Well, therefore, CDA must equal 2x. There you are. Bob's your uncle. It's done. Prove that CDA is 2x. Give reasons for each stage of your working. That's question 6. Finished.